What happens if you fall into a black hole? On the outside, we know the script. Space stretches, time slows, light bends, and physics starts to break. From far away, you'd look frozen in time, your image smeared and red-shifted as light struggles to escape. But cross an invisible boundary, and something even stranger happens. The normal rules of space and time stop applying. What happens next is still one of the biggest mysteries in the universe. Today, we're going to cross the event horizon and explore 5 leading theories about what might exist inside a black hole. Here's what we do know. A black hole is a region where gravity becomes so strong that nothing can escape. Not gas, not matter, not even light. Get too close, and every path you could take curves inward, deeper toward the center. The surface of no return is called the event horizon, the edge of a waterfall in space-time. From the outside, it just looks like empty space. No wall, no glowing ring, no warning sign. But once you cross it, every path forward leads only one way: down. Beyond that invisible boundary, our current physics breaks down. So what could actually be waiting inside? Theory number 1 is the classic nightmare ending, all matter crushed into an infinite point. This is what falls straight out of Einstein's general relativity. Follow the equations all the way in, and they predict that gravity becomes infinite density, becomes infinite space and time collapse, and the laws of physics stop making sense. Everything that falls in gets squeezed into a single dimensionless point called a singularity. No size, no volume, just pure concentrated mass and energy in a place where the known laws of nature simply fail. The problem? Infinity is usually a sign that our math has hit a wall, not that nature literally builds impossible objects. So many physicists think the singularity, as predicted by relativity, isn't the final answer, but a clue that something new has to take over inside. Enter theory number 2. The inside is not a point. It's a superdense quantum object. If general relativity describes gravity, quantum mechanics describes the tiny building blocks of reality. And quantum mechanics absolutely hates infinities. So some scientists think that when matter collapses, it doesn't shrink to an infinitely small point. Instead, it stops at the smallest possible scale, the Planck scale. In this picture, the singularity is replaced by a quantum core, a region where space becomes discrete, like pixels, time ticks in tiny steps, and gravity itself becomes quantum. Space-time turns into a chaotic quantum foam. Imagine a dead star collapsing until it's as small as the fundamental grid of the universe will allow. From the outside, it still looks like a black hole. But inside, instead of a mathematical disaster, you have an exotic quantum object obeying new rules of physics we haven't fully discovered yet. Some theories go even further. What if the inside of a black hole isn't just dense? What if it's big? Black holes may be portals. This is where things start sounding like pure sci-fi. Except a surprising number of cosmologists take versions of this idea seriously. According to some models of space-time, the singularity isn't an endpoint. It's a bridge, a tunnel, a connection from our universe to another region of space-time. In these models, the collapse doesn't end in destruction. Instead, it pinches through and opens into a new expanding region, sometimes described as a baby universe. From our side, we just see a black hole, a dark sphere that swallows anything that gets too close. An object that can only spit matter and energy out, never take it in. This leads to some wild possibilities. Black holes could be seeds of new universes. Our own universe might have started inside a black hole, and reality could be a branching tree of connected spacetimes. Right now, there's no experimental proof. We can't jump in, take a look, and report back. But mathematically, these hidden universe models are possible, and they raise a disturbing question. Even if a black hole leads somewhere else, can anything survive the trip? You are stretched into a thin stream of atoms. This is the most famous black hole death scenario. It's not about what the black hole is, but what it does to you as you fall in. Near a black hole, gravity changes very quickly with distance. If your feet are closer than your head, gravity on your feet is stronger than gravity on your head. Your body is pulled harder at the bottom than at the top. You're stretched into a long, thin filament, and the forces rip apart molecules, then atoms, then even subatomic particles. Scientists call this process spaghettification. For a small black hole, this would kill you before you reach the event horizon. For a supermassive black hole, you might cross the horizon first, only to be shredded deeper inside. Spaghettification gives us a brutally vivid picture of what happens to matter. But it still doesn't answer our key question: what is the black hole itself on the inside? A wall of energy destroys everything at the boundary. For a long time, physicists believed that if you fell into a large black hole, you wouldn't notice anything special at the event horizon. You'd just drift past the point of no return, unaware you'd crossed it. But then a paradox appeared. How does a black hole keep information about what fell in without breaking the rules of quantum mechanics? One radical solution is the firewall hypothesis. In this idea, the event horizon isn't smooth or gentle at all. Instead, it becomes a blazing wall of high-energy radiation, a thin shell where space-time itself violently breaks down. If the firewall is real, then nothing truly passes through the event horizon. Everything is burned up and encoded at the surface. The singularity never forms, and the interior of the black hole might not exist in the way we imagine. It's physics rewriting itself to protect information and avoid paradoxes, but it also breaks another principle, that crossing the horizon should feel normal. So right now, the firewall idea is still extremely controversial. Some researchers think it's the key to solving black hole information loss. Others think it proves we're still missing a deeper, unified theory. Here's the honest answer: we don't know what's inside a black hole. Black holes are the universe's best-kept secret. We can study their shadows, detect their gravity, watch them collide and send ripples through space-time. But the interior, the region beyond the event horizon, is sealed off from us by the very laws of physics. No light can escape to bring us a picture. No probe can send back a signal until we develop a working theory of quantum gravity, one that unites general relativity and quantum mechanics. We may never be able to say, with certainty, what really happens beyond that invisible edge. What we do know is this: every serious theory we have points to a universe stranger and more extreme than our everyday intuition can handle. Whatever is inside a black hole, it's almost certainly wilder than anything we've put on screen so far. If this video bent your brain, subscribe for more cosmic mysteries and comment which theory you think is closest to the truth.